So this is feeling like a three-part lecture. Um, each of the problems in section 1.8 is an equation because it has an equal sign. All of the problems we've done so far in this section have been expressions. Expressions don't have equal signs. When you have expressions, you can combine like terms, you can simplify, you can rewrite, but you don't get numerical answers. When you have equations, you expect numerical answers and you can check those answers. For each of the problems in section 1.8, we're using a property of numbers. I guess it's like the zero product property. I don't know if that's exactly the name, but it's a name that's suitable. And basically the zero product property says if you are multiplying two or more numbers, the only way the product is zero, or the result of multiplying is zero, is if at least one of the numbers is zero. And that's actually supposed to be obvious, maybe not even worth writing. For example, if I multiply two non-zero numbers like 2 and 3, I'm not going to get 0. If I multiply two non-zero numbers like 2 times 3 times 4, that's going to be 24. That's not going to be 0. But if I multiplied 2 times 0, that's going to be equal to 0, because if I'm multiplying a string of numbers, 2 or more numbers, and one of them is 0, then the whole product would be 0. If I multiplied 3 times 0 times 4, I did it on my calculator to show you 3 times 0 times 4, that's still 0. So the zero product property says in a string of multiplications, if you're multiplying several factors, if one or more of the numbers is 0, the result's going to be 0. If none of the numbers is 0, you can't be 0. And that's the strategy that we're going to use to solve all the problems, the theory behind all the problems in section 1.8. Although when we're doing the problems, it's not going to be maybe so obvious that I'm using this theory. To solve each of the problems between 1 and 21, the right side of I'm looking for a numerical answer because there's an equal sign. The right side of the equation is a 0. In order for the left side, when I multiply it out, to equal the right side, either the x plus 3 or the x minus 5 has to be 0. To solve the problems between 1 and 21, which the left side is factored and the right side is 0, I simply take each factor, the insides of the parentheses if there's a parentheses, set the factors equal to 0, and do the algebra to isolate the x. The factor of x plus 3, which comes from the first parentheses, if I do the algebra to set it equal to 0, that would be subtracting 3 from both sides. I'd get one answer of x equal to negative 3. If I work with the factor of x minus 5 and isolate the x by adding 5 to both sides, I'd get the other answer of x equal to 5. I claim that there are two different answers to this problem. There are two different numbers I can plug in for x and get the left side equal to the right side. When we're solving an equation, a problem with an equal sign, I expect numerical answers, and numerical answers are only correct if when I plug them in, both sides of the equation simplify to the same number. Let me show you how I can check. I'll check a lot of these problems. I'll check the easier one. I'll check it by hand. I'm going to check the positive x equal to 5. To check x equal to 5, I'm going to change both the x's in the original problem to 5. Because the x's don't have exponents or coefficients, I won't need a parentheses. I'm going to change the 5 in the first parentheses, the x in the first parentheses to 5, the x in the second parentheses to 5. What I've done right now, if I simplify the first parentheses, I get 8. The second parentheses, I get 0. I've kind of created something that has a zero product property. Here I'm multiplying on the left side. I want the left side to multiply out to be 0 because that's what the right side is. In order for an answer to be correct, the left and the right side have to be the same. And that magically happens because one of the factors is 0. I don't know how much room I have. I'll try to jam this up here. Let me show you the checking the x equal to -3. To do that, I'll do -3 plus 3 in the first parentheses, -3 minus 5 in the second parentheses, and I'll simplify the inside of each. The first parentheses, -3 plus 3, gives me 0. The second parentheses, -3 minus 5, gives me -8. Again, this is the zero product property in hiding. I want, when I check my answer, for the left and the right side to be the same. Because the right side is 0 and the left hand side has multiplication, the only way the left hand side can multiply to be 0 is if one of the numbers is 0. And this 0 times -8 is 0. So I've checked both answers. When I plug them in, I get 0 on both sides, so I feel good. Maybe I won't check everyone because this will get too long. Let me move on to number 4. Number 4 is structured the same way. Left side is factored, the right side is 0. Because there's an equal sign, I expect numerical answers. Because the left side is factored and the right side is 0, I can get the answers, the numbers I can plug in for x to make the left side 0, to make it match the right side, by separately taking the insides of each parentheses and setting them equal to 0 and isolating the x. The x minus 9 factor, to set it equal to 0, I'd add 9 to both sides and get x equal to 9. The x minus 10 factor, I'll add 10 to both sides and get x equal to 10. For an answer to number 4, I prefer writing one letter followed by any number of answers separated by a comma. My standard answer would be the letter followed by the individual answers separated by a comma. I could, and the order doesn't matter, I didn't have to write the 9 first and the 9 second. I could have written x equal to 9 and x equal to 10 for an answer. That would be equally good. And if I want to, I could be lazy, but sometimes teachers don't like laziness. I could have just written 9 and 10. These are answers because if I plug 9 in for x or 10 in for x, both sides will come out to be 0. I'll check this real quickly to show you that it works. If I wanted to check the x equal to 9, I'd go for both of the x's on the left-hand side. I'd go 9 minus 9 times 9 minus 10. That's what the left side would happen if I change both x's to 9. For my answer to be right, the left side has to multiply out to be 0, and it will, because inside the left parentheses, 9 minus 9 is 0. Inside the right parentheses, 9 minus 10 is -1. And 0 times anything is 0. So when I plug in 9, I get a correct checking. If I plug in 10, I'd have to go 10 minus 9 times 10 minus 10, and that would have to be 0. This is going to give me 1 times 0. Again, the only way the left side is going to come out to 0 when I plug numbers in for x's is if one of the factors turns into 0. And it does, and this will give me a big old check. I might start checking on my calculator to speed up the process when I choose to check. For problem 6, left side is factored, the right side is 0. I'm going to get my answers just like I did for problems 2 and 4. Set the inside of each parenthesis separately equal to 0. It's going to take 2 steps to isolate the x. The 2x minus 12 equation that I need to solve, I need to first add 12 to both sides. That's going to give me 2x equals to 12. And then I'm going to divide both sides by 2. That's going to give me one of the 2 answers of x equal to 6. The 3x plus 15, to get the answer that comes from that equation, I'm going to minus 15 from both sides. That's going to cause the 15s to cancel on the left-hand side. It's going to give me 3x equals negative 15. And then I'm going to divide by 3, divide by 3. The left-hand side, the 3's cancel, I'm left with an x. On the right-hand side, negative divided by positive is negative. 15 divided by 3 is 5. I get negative 5. My answer I'll box without writing the word answer. My answer is 6 and negative 5. If I want to check, I can check on my calculator. If I wanted to check, I probably am going to insert a parentheses because of the coefficients. If I want to check the x equal to 6, I should put a 6 in for the x in the first parentheses, do 2 times 6 minus 12, and put a 6 for x in the second parentheses, do 3 times 6 plus 15, and I could enter that whole left side on my calculator. I can go parentheses 2 parentheses 6 minus 12, close out my parentheses, that's the first factor, and then parentheses 3 parentheses 6 plus 15, and my parentheses. This is simplifying the entire right side on my left side on my calculator without doing any algebra by hand, and it works perfectly. The left-hand side simplifies to equal to the right-hand side. I'm going to skip checking the negative 5, but I could do it the same way. I'm going to check here when I get these fraction answers for number 8. Number 8 is in the same grouping of problems, so I'm going to do the same structure. I'm going to go is 5x. I'm going to set the factor of 5x plus 4 equal to 0. I'm going to set the factor of 2x minus 3 equal to 0. Each of these is going to give me fraction answers. If I didn't have a calculator handy, I probably wouldn't check, but since I have a calculator that I'm comfortable with, I'm going to check these. I'm going to get the answer to each equation. For the 5x plus 4, I'm going to start off by minusing 4, and then I'll divide by 5. Left-hand side, when I divide by 5, is going to give me an x. The right-hand side is going to give me a fraction answer. That's going to be a pain to check by hand, not so hard to check on my calculator. The 2x minus 3, I'm going to add 3 to both sides and get 2x equals to 3, and then divide both sides by 2. On the left-hand side, the 2's cancel, I get the x. On the right-hand side, I get the second answer of 3 halves. I'm going to box and write my answer how I normally do, usually one letter, and I put, if there's multiple answers, I separate them with a comma. I probably wouldn't want to check this by hand, but I can. But checking it on my calculator is not particularly hard. If I want to check the x equal to negative 4/5, that means I need to put that x and that x inside of parentheses, or negative 4/5 in place of that x and that x inside of parentheses. So checking, I'd go 5 parentheses negative 4/5. That actually multiplies out to be negative 4 plus 4 times 2 parentheses negative 4/5, close my parentheses, minus 3. And that answer is only right if when I plug this in, either by hand or on my calculator, I get 0 out. So I'm going to go parentheses, 5, parentheses, fraction, negative sign by the fraction, 4, get down to the denominator, 5, close that first parentheses, and then plus 4. That's the first parentheses entered. That one's actually going to be the 0. And now the second parentheses, parentheses 2, parentheses fraction, negative 4/5, out of the denominator, close my parentheses, minus 3, close the parentheses. That's exactly this. When I hit equals, it tells me that this whole left side simplifies to 0, which it needs to do for it to be a correct answer. It needs to match the right side. The next checking I need to do is I need to go 5 times 3 halves plus 4, and then 2 times 3 halves minus 3. That needs to be 0. I'm going to cheat check. On my calculator, I could just use the back arrow, and as I'm using the back arrow, I can get to the fraction. This denominator, if I hit the delete key, I can change to 2. Could run up to the numerator, delete, delete, change that to 3. So that's got the second parentheses correct. And I'll back, get to the denominator, hit the delete key, make a 2 in the denominator, run up to the numerator, delete, type 3. So without having to type everything, I have everything written in just by using the arrow here in the delete. When I hit enter, it gives me 0. So I've checked both of these, but I didn't really have to check both of these. The next 5 or 6 problems that I'm going to do have common factors with x's. And if this is factored, it has 3 factors. That first factor, if I was given a problem, would have came from a common factor. It's a big deal that common factors, when they're in these kinds of problems, common factors that have an x or whatever variables in the problem give an answer of 0. When I look at problem 10, there's a common factor of 3x and x minus 4 and an x plus 5. This is going to have 3 answers because there's 3 factors with x's. In order to solve number 10, I'm going to set 3x equal to 0. I'm going to set x minus 4 equal to 0. And I'm going to set x plus 5 equal to 0. The 3x, to set it equal to 0, I'll divide both sides by 3. On the left side, the 3's cancel. I'm left with an x. On the right side, any fraction with 0 in the numerator is equal to 0. So that's the common factor with an x. It gives a solution of 0. The x minus 4, to get the solutions from it, I'll add 4 to both sides. And the x plus 5, to get the solution from it, I'll minus 5 from both sides. I get 3 separate answers. They all can be checked. I'm not going to check all 3. I'll just show you that 0 works. I'm just going to check the 0. I could check all 3, but the other 2 are not anything new. But the 0 answer is new. Common factors with x's give solutions of zeros. And if I wanted to check this to make sure that 0 is in fact an answer, my orders of operations would be to simplify the parentheses. The first parentheses, 0 minus 4 is negative 4. The second parentheses, 0 plus 5 is 0. And now I need to multiply 3 times 0 times negative 4 times 5. I know that's going to be 0 because if in a string of multiplications, if any of the numbers is 0, the whole product is 0. And so I've checked that. I could check more. I could check the 4 and the negative 5, but I'm already 18 minutes into this and I want to keep getting some stuff done. Problem 12 has a common factor with an x, so it's going to give a solution of 0. To answer 12, I would set the common factor of 4x equal to 0, set the factor of 2x minus 10 equal to 0, and set the factor of 3x plus 15 equal to 0. The common factor of 4x is going to give me an answer of 0. I'll get that by dividing by 4. On the left-hand side, if I divide by 4, I'm left with the x. On the right-hand side, I have a fraction with 0 in the numerator, and that's equal to 0. The 2x minus 10, if I'm solving for x, I'm going to add the 10 and get 2x equal to 10, and then divide by 2, divide by 2. On the left-hand side, the 2's cancel, leave me with the x. On the right-hand side, 10 divided by 2 is 5. The 3x plus 15, I'm going to subtract 15. If something's added, I subtract it. If something's subtracted, I add it. That gives me 3x equals to minus 15. And then I'm going to divide by 3, divide by 3. On the left-hand side, the 3's cancel. I'm left with the x. On the right-hand side, negative 15 divided by 3 is negative 5. When I write my answer, I like writing 1x, and I like separating the answers with a comma. Sometimes it happens that you get the same number, positive version, negative version of that number as an answer. Another way to have written this answer would be x equal to 0 and then comma. Then instead of writing positive and negative 5 separately, we can write this plus or minus symbol preceding the 5. That means 5 and negative 5. This is a shorthand for writing 5 and negative 5. It's really not that much of a shorthand. I don't know really how much I saved in terms of writing, but it's a common way to write, so you should be just comfortable looking at it. All right, so 14 has a common factor with an x that gives a solution of 0. If I'm solving 14, I'm going to go x equal to 0. There's no algebra to show me that that's the solution because that's already solved. I'm going to do x plus 1 equal to 0 and x plus 2 equal to 0. The x equal to 0 is my first answer. The x plus 1, to get the answer from it, I'm going to minus 1 from both sides. The x plus 2, to get the answer from it, I'm going to minus 2 from both sides. So I have that common factor with an x that gives a solution of 0. In this case, it gave me the solution without extra algebra. And the other factors give me the non-zero solutions. 16, it's ugly. Common factor of x gives a solution of 0. The other pieces are going to give me fraction solutions. I can check them, but I don't have to. So first I get x equal to 0, common factor with an x. And now I'm going to add 10 and divide by 7. To give me x equal 10/7 for my second numerical part of the solution. And then plus 16 to get the 3x minus 16 going. Divide by 3, divide by 3. I prefer improper fractions as opposed to mixed fractions or decimals, so I'll leave them there. For my answer, I get 3 solutions to number 16. It's going to be x equal to 0, x equal to 10 over 7, and x equals to 16 over 3. Those will all check. The next few problems have common factors that don't have an x. Common factors that do not have an x, this is going to be a double negative, which is horrible, but it is what it is, that have no x, do not give a solution. And that's the next few problems. So the difference between 16, 14, and 18, in 14 and 16 the common factor had an x, in 18 the common factor doesn't have an x. Algebraically, to solve 18, I can go 4 equal to 0. Since there's no x, there's no solution. 4 is not an answer. I'll show you in a second that it's not an answer by trying to check it. The x minus 3, it has an x. The algebra will produce a solution that checks unless I make an math error. The x minus 3 gives a solution of 3. And the x plus 5 gives a solution of negative 5. If you can get the answers in your head without showing this algebra, that's, preferred, really. This is trivial algebra that most students can do in their head. So the answer to problem 18 should be x equal to 3 and x equal to negative 5. If you included the 4, it's not a number that checks. If I went through and changed both of these x's to 4, I'll show you that it doesn't check. If I tried to check x equal to 4, I'd go 4 times 4 minus 3 times 4 plus 5 equals to 0. I'll do the parentheses. The first parentheses, 4 minus 3 is 1. The second parentheses, 4 plus 5 is 9. And this is 4 times 1, which is 4 times 9, which is 36. This is what happens when an answer doesn't check. you get something that's not a true statement. It can be any false statement. In this case, 36 equal to 0 is not true. So it's important to understand common factors that are number times x or just the naked x give a solution of 0. Common factors that are number without a letter don't give a solution. So just a few more. You have 19, I have 20. For 20, I have a common factor that doesn't have an x. It's not going to give a solution. Only common factors with an x give a solution, and they give a solution of 0. The factor of 4x minus 1 is going to give me an answer of 1/4. If you could do it in your head, don't show this algebra. The algebra would be to add 1 to both sides. That would give me 4x equal to 1, and then divide both sides by 4. Cancel the 4's on the left side, left with the 1/4 on the right side. The 3x minus 5 is going to give me a solution of positive 5/3. If you can do it in your head, do it in your head. If not, the algebra would be to add 5 to both sides. That would give me 3x equals to 5. And then to divide by 3, that's going to give me x equal to 5/3. For an answer, I'm going to write x equal to 1/4, comma, 5/3. I'm going to break and do a part 2. If I had to guess, I think there's going to be 4 parts. There's 4 sections of problems in section 1.8, and they're probably all going to get their own video.